Today I will introduce you to inferential statistics. Part 1 is introducing the concept of inferential statistics and t-test. After this session, you should be able to understand why researchers use inferential statistics and also to understand t-test results when they are reported in the journal papers. So we move from descriptive to inferential statistics. Descriptive statistics refers to the use of means, percentages, frequencies in order to describe the characteristics of our data set that is collected for a sample. Now, from that, we make inferences to the population from which we took the sample. So that's when we use inferential statistics. So when I say we make inferences, it could mean that we make predictions of what the population characteristics are like based on what we have studied of the sample in our study. So we may study just one group of university students, but when we use inferential statistics, we are essentially saying that the results apply to the whole population of university students in the country. Sampling error. This is one concept that you need to understand. In inferential statistics, sampling error is unavoidable. And this is because we only study a sample, a small part of the population, and there is this larger portion of the population that is not studied. So what we find out may not be representative of the whole population. And this happens, sampling error happens even if we do random sampling. But one way we could minimize the sampling error is to increase the sample size as much as is feasible. Well, if we study the whole population, then the sampling error drops to 0. Another concept you need to know is the confidence level. Social science research usually accepts 95% confidence level, which means the probability of error is 5% or less, written as P less than 0.05. What does confidence level mean? Let's talk about 0% confidence level. If we have 0% confidence level in the results, it means that we have no faith at all that if we repeat the results, we will get the same results. Now, 100% confidence level means that if we repeat the study, we are very sure we will get the same results. However, in reality, in statistics, there is no such thing as 100% confidence level. So in the social sciences, what we've taken is 95% confidence level. And in the sciences, they usually go for 99% confidence level with less margin of error. Here, I will introduce to you the first of the inferential statistical tests called the student's t-test. T-test, what do we do with it? When we use a t-test, it is because we want to find out whether two groups are similar or different. For example, we can look at two species of cats in terms of their ability to catch mice, the Siamese cat and the local cats. We put them in a room that is specially set up and conduct an experiment. And we measure or count the number of mice they manage to catch in a set time. So when we compare the number here and we run the t-test, we will find out whether the group of Siamese cats or the group of local cats, whether they are the same or significantly different in their ability to catch mice. When we run the t-test, essentially, we are using formulas to compare the means or the average of the two groups. What do we do? Well, I have talked about the outcome of it. When we've got the results, we count the number of mice. Now let's go back to the beginning when we start the study. When we start the study and we formulate the research question, we need to set our mind on this. Form the hypothesis for testing of the for testing later on. Okay, for the example of the cats, we don't know which group will be better, so we form a non-directional t-test, a two-tailed t-test. The null hypothesis is that there is no difference between the two groups of cats. And the alternate hypothesis is there is a difference in the mice catching ability of the two groups of cats. So the null hypothesis will always go for no difference, and the alternate hypothesis will go for a difference. And this is for a two-tailed t-test. For a one-tailed t-test, one of it will say A is bigger than B, and the other one will say B is bigger than A. Yeah. So let me show you this. For t-test, there are three situations where we will compare two groups. The first of this is what we call a simple single sample t-test. There is only one group, and it is being compared with the population from which the group is taken. For example, we study coffee drinkers as a group of people compared against the whole population. So what do we compare here? The number of hours they are awake, and the mean M equals to 17.8. Average hours they are awake is 17.8. Okay, are they different from the population as a whole? Let's look at the results here. Coffee drinkers spend more time awake than the population as a whole. What do T bracket 28 mean? This means the degree of freedom is 28. Here, the degree of freedom is calculated in this way, n minus 1, because there is only one group. So that means the total number of participants studied here, or coffee drinkers here, is actually 29. Minus 1 equals to 28. That is the degree of freedom. Next, you see in pink color 2.6. This is the T statistic that is calculated for this group of coffee drinkers. This is the T statistic, which is supposed to be compared with the T critical in the T table. And I have found that the T critical here is 2.048. And this is based on the 95% confidence level that is set. So the p-value here you can see is p less than 0.05. If the researcher has reported that p is less than 0.05, it means that the results are significant. This group of coffee drinkers are significantly different from the population as a whole in the amount of time they are awake. We will come back to this comparison of the T critical and the T statistic later using a graph, and you will understand this better. Now, this is the T test table showing the T critical values. I have shown you in pink boxes, so let me highlight to you what you should look at. At the top, you see one tail and two tails. So since we ran a two-tail t-test, please look at 0.05. So in this box coming down, it will intersect with the degrees of freedom. You see, just now we said the degree of freedom was 28. So it intersects and at 2.048, and that is the T critical. So what do we do with this value? You see, this is a graph of a confidence level. You can see in the middle is 0, 95% confidence level. There is an upper limit and a lower limit. So just now at 28 degrees of freedom, P set at 95% confidence level, the T critical that was found from the T test table is 2.048 on the plus side and on the minus side. Because this is a non-directional or two-tailed t-test, it could fall into either regions of rejection. And the value we calculated, called the T statistic, is 2.6. 2.6, as shown by the pink arrow, is more than 2.048. So it falls into the rejection region. Marked in white here, you can see that. So you can reject the null hypothesis. The null hypothesis just now said there is no difference. So when you reject it, it means the two groups are significantly different. In the example just now, the coffee drinkers, number of hours being awake is different from the general population. So here I have shown you a graph where we increase the confidence level from 95% to 99%, and you can see that the region for the rejection of the null hypothesis becomes smaller and smaller. So your t statistic needs to be bigger for it to be falling into that region. And what this means is that the differences in the means need to be much greater for the null hypothesis to be rejected. Now, let's look at the second condition where we compare two groups. Just now was a single group compared against the population. Here we compare two different groups that have nothing to do with each other. I show the first set of results here, which says that the 25 participants who received the coffee intervention compared to the 28 participants in a control group demonstrated significantly better memory recall scores. P equals to 0.04. Here, degrees of freedom is 53 minus 2 because there are two groups equals to 51. And you note that P equals to 0.04, which is less than 0.05. 4% is smaller than 5%. That means that the two groups are significantly different. The coffee drinkers and the control group, they are significantly different in how well they remember something. This is the second set of results, maybe from a different study, which shows that there was no significant difference between the coffee drinkers group and the control group in their memory recall. No significant difference. Okay, why? Because P equals to 0.097. You will know that 0.09 is bigger than 0.05. 9% is bigger than 5%. So it is not significantly different. The two groups are not significantly different. Even though you see that the means 85 and 83 are a little bit different, but actually the difference is too small to be obvious. So this is how you interpret the t-test results. And finally, there is this third condition where we compare two groups. Now, what happens in a dependent t-test is that the two groups are actually the same, but they are like the before and the after measurement, like this cat here, before the beauty treatment and after the beauty treatment. So it is the same group. So the results from the pre-test and the post-test in the memory task indicate that the presence of caffeine in the bloodstream resulted in improvement in memory recall. So there is comparison of pre-test and post-test and shows that there is a significant difference. P equals to 0.006. 0.006 is much, much smaller than 0.05. Okay, so the results are significant. This is how you interpret it, whether it's significant or not, if it is not even written in words. But the two sets of information will be consistent. What is reported here and what is shown in the p-value, it will be consistent. And you can also see the means 13.5 and 16.2. But judging from the means alone, we do not know whether they are significantly different. So we need to run the t-test and compare the mean, and then we will know from the p-value whether they are significantly different. So you have seen three conditions where we compare two groups using t-test. First group was a single group with the whole population. The second condition was two independent groups. They have nothing to do with each other. And this third and last condition is the same group but measured 2 times. All right, thank you.